viscosity, and then the wake. This force over surface is usually called tau. The Greek letter tau is you know, the T in Greek. They taught in school. I learned to make the capital T like this, tau. That's why they taught me. So force over surface is called tau. Is the shear force, or shear force. Shear is what the scissors do. You know, you cut in this direction, you know, but you apply the force. You apply a shear force, you know, in perpendicular direction. That's shear. Shear force means tangential. Okay, and this wake is usually represented as the derivative has a point and usually with a gamma. This is called gamma dot. Gamma is the Greek letter gamma, alpha, beta, gamma, and the dot is the dot I draw here, meaning the derivative. So using this notation, this equation is usually written as eta gamma dot. Okay. Gamma dot is usually called shear velocity. The same idea, the shear, tangential, and velocity. This is not perpendicular to the fluid, but tangential. Okay, in the different layers. Shear velocity. Shear velocity. So this is the Newton's law of viscosity. Why is this equation important? This equation characterizes what Newton thought it was all fluids, but now we know that only applies to, Alexa, stop, to a particular type of fluids called Newtonian fluids, whose viscosity doesn't change with agitation. Okay, so we don't have more time. But what we have to, it has to cool down. So yeah, this is also physics. I'm using I don't know how to call it, pressure cooker. I don't know how to call it. In Spanish we call it the equivalent of express pot. So now I can't open it. So if I open the gas, it will fill the room with gas. Don't believe me? Yeah, but we can see it because what I did. The pressure inside is high, but when I apply cold water, pressure dropped. So now I can open it. See? Just like drop in temperature is the ideal equation for ideal gases, the relation between pressure and temperature. Anyway, nothing to do. Forget it. Because we're in Newton's law for viscosity. So it only applies to forget. We saw an experiment, and this experiment led us to the relationship between force, surface viscosity, and wake, the movement of the fluid. Okay? So, using the experiment, we could relate them. We could see that the force to move the fluid depends on several factors. The main factors I mentioned, the surface, the viscosity, and the wake. And we just wrote in another notation, the more common, which is this one. Okay? Why is this important? We're going to see in the next videos that all the fluids that enter in contact, that touch the body, both the inside and from the inside point, inside fluids that you drink, and the outside, okay, must be characterized. The behavior must be characterized because we have to understand how the fluids behave, so we can predict the interaction of fluids with the body. So this is the basic equation that relates relates the force, surface, viscosity, and the velocity of the fluid. That's the basis we're going to use for the study of viscosity. This is a particular branch that I mentioned before, a branch of physics, but it's also chemistry, also share part of this, called rheology. Rheology is just the study of flows, of fluid moving, okay? Yeah, so we started this part, the study of characterizing the fluids, particularly hungry viscosity. Okay, I hope you understand and enjoy this, the continuation of this experiment. And we get in deep into equations that we're going to explain later. Okay, bye.